Good morning everybody and welcome to the second webinar in our How to Be Bold series. My name is Harry Adams and I'm the strategy lead at Red Badger. So for those of you who've not come across Red Badger before, just do a little brief intro before we get to the exciting bit. So we're a digital consultancy and we're focused on the digital transformation of large companies through innovation and delivery expertise. We have a proven track record of being catalysts for change for our clients, and we often help them to navigate the open source revolution and be bold with their tech choices. We really believe that technology should be as invisible as possible and enable you to focus on delivering business value. By being tech agnostic, by choosing the right tech for the job, and by being meticulous in engineering practices, we will enable continuous delivery, speed to market, and create value for customers quickly. So, how do you know to trust us on this webinar today? So we love exploring new technology and understanding the problems that technology can solve for our clients. Our delivery teams have been using both GraphQL and Serverless for a number of years. The first implementation of GraphQL we did for over 2 years ago for one of the world's largest retailers. And in 2015, we built a microservices app that was fully serverless for car trawler. Since then, we've used both GraphQL and Serverless on numerous projects when it makes sense. So, over to the experts in the room. So firstly, I'd like to introduce Stu, who's our founder, well, one of our founders and chief scientist, and Andy, who's one of our tech leads, who'll be talking to you today about both of these technologies. So, Stu, talk to me a bit about GraphQL. What is it?
Well, it's a next generation API technology from Facebook for surfacing a full data model from a single endpoint. It was born from their commitment to support old versions of iOS and Android applications going back 2 years. And you can imagine that lots of people don't update or don't have auto updates on their phone. And so supporting old versions of clients can be a bit challenging sometimes, especially with RESTful endpoints. You can have like /v1, /v2, /v3 across the whole thing, and it's really difficult to keep all of those maintained and serviceable. So, so GraphQL was born from that really. It's been in use at Facebook for 5 years or so. It's actually just a specification and a reference implementation in JavaScript, but there are open source implementations in all languages for both clients and servers. So if you think about like the history of APIs, we've had like RPC, then we had like SOAP, and then, which was a bad idea. They tried to put the whole of the HTTP mechanisms inside the message, and it was seen as a mistake really. So then REST came along, which was going back to the roots of the web and leveraging the HTTP mechanics effectively to help with all this stuff. And then now GraphQL is here. So what it is the client sends a query to the server to specify exactly what data they want and exactly the shape that they want that data in. So it supports queries, which is the read stuff, mutations, which is the write stuff, and subscriptions when you want to be notified when data on the server has changed. And it's a great decoupling point between the server and the client, allows them both to evolve on their own roadmaps.
That's really interesting. So, in your opinion then, what are the main problems with API development today?
Well, thankfully we're largely rid of SOAP already, but there's still lots of REST out there. There's nothing wrong with REST. It's a great thing. As I mentioned earlier, the problem with it, I think, is with the versioning, /v1, /v2, and maintaining all that stuff that we talked about earlier. You get massive endpoint proliferation across the whole thing. So condensing all that into a single endpoint, where any client can effectively request whatever data they want. So you can support all sorts of different applications from one endpoint, all sorts of different versions of those applications going back from the same endpoint, and that is a killer feature.
Fantastic. So you've mentioned sort of some of the challenges, I think, of API development. How does GraphQL solve all of these problems?
So it's largely down to the client being able to specify what data they need. So if you call a RESTful endpoint, you're going to get the response back that you're going to get, and it's going to have data in it, and you might only be interested in a certain amount of it, but you're going to throw the rest away. So you're overfetching, so there's bloat on the wire. Or worse, you might be underfetching, and underfetching is where the data you want isn't going to response, and then that's a big problem, because then the developers on the API developers have got to actually add that stuff. And it's really good on mobile devices where you've got poor connections, because typically RESTful APIs are very chatty. You make lots of requests, you stitch the data together on the client. With GraphQL, you can make one request to the server and get the response back in what you want. So if you're a mobile device on a train or something going through a tunnel and a poor 3G connection, it's great, because it reduces the amount of data on the wire and the number of calls that you're going to make.
That's brilliant. So I'm sure some people listening in on this might have some concerns about stability and backwards compatibility. How does GraphQL solve some of those problems, or look to work with them?
So from a stability perspective, I mean, Facebook have been using this, obviously one of the biggest sites on the internet, for years. So they've basically proven it, and they're very good at proving their open source technology. But there are multiple clients, as I mentioned before, and they're largely open source. There's servers, there's GraphQL servers in every language and clients in every language, and they're all open source, and your mileage may vary with those things, same as any open source projects. But largely it's been battle tested by Facebook. As far as the backwards compatibility is concerned, we only ever add stuff, we don't remove it. So instead of removing stuff, fields, for instance, we mark them as deprecated, and that means that old clients can still access it, they can still make the queries they've always made, but new clients wouldn't see that. So if you're exploring the GraphQL endpoint via its schema-driven, strongly typed effectively, then you won't see the deprecated field. So new clients, so there's a way of basically aging out that if you've got analytics on there, you can work out when the last clients are using those old deprecated fields, and then you can, but it's largely all about backwards compatibility.
Brilliant. So let's imagine that I'm part of a large organisation. GraphQL sounds like something I might want to get started with. How would I go about adopting GraphQL?
So I think largely it's easier for developers to consume a GraphQL endpoints than REST endpoints. I mean, it's subjective, but I think there's a better developer experience, which is great. They can form the queries they want to make, and life's good. It simplifies applications quite a lot. But there's a single endpoint, so there's collective responsibility for that whole thing. You can still organise your teams around domain boundaries or around products that, but there is an organisational burden effectively of making sure that the endpoint, everything comes together in one place. As far as migrating to it is concerned, it's really straightforward, because you can put a RESTful endpoint in front of a whole load of, a GraphQL endpoint in front of a whole load of RESTful endpoints. And so what happens is that the query comes in, it's analysed on the server with a depth first sort of algorithm, and there's resolvers on each node, and those resolvers can just call the RESTful endpoint. So you can put a very thin GraphQL layer in front of your RESTful endpoint. Or you can do it the other way around, and you can put RESTful, you can effectively make your RESTful endpoints submit GraphQL queries to a GraphQL endpoint. So you can do it both ways, and it's fairly easy to do that without breaking clients that depend on those RESTful endpoints, and until they've been upgraded as well, and you can get rid of them.
Okay, well, I'm sold. But in your experience, there must be some negative or some drawbacks of GraphQL. Can you talk me through those?
There always is, right? I think the big thing for me is that it's harder to leverage the infrastructure of the internet which is there to help with caching, like caching proxy servers, CDNs, all that sort of stuff. You know, the HTTP has a very specific way of specifying in a response, how long that can be cached for. And when you're making GraphQL queries, what tends to happen is that you're making lots of different queries and and lots of different data in the response, and it's less likely that you're going to get cache hits. You can still do caching. I think that's somewhat mitigated by clients like Apollo and Relay, which do cache fragments of the response data locally on the client, so that and then will actually only request the data that they don't have already, so that's not so bad, but it's still not as easy as it is with the rest. The other thing is that field-based protection, role-based access control, is harder. It's a separate thing. You have to put it in yourself. Authentication is separate. Authorization is separate. These are things you have to add on. And you also need to think about what happens if a client makes a recursive query, because it's a graph of data, GraphQL. You can make recursive queries that could go on, infinitely, and you could overload the server that way, so like a denial of service type thing. So you need to protect against that.
Interesting. So you mentioned Facebook already as one of the prolific users of GraphQL. What other large organisations have adopted GraphQL?
Well, famously, GitHub have moved their whole API over to GraphQL in the last 12 months. They started it 12 months ago, and it's been in production now for a month or two. And there's some interesting talks that they've done around their journey, and how they went from no GraphQL to full GraphQL in 12 months. Twitter are well on their way to migrating to GraphQL. Yelp have done it. Shopify is based on GraphQL. There's lots of really big sites that are reaping the benefits of it. Yeah.
Fantastic. Well, thank you very much. That was insightful. Andy, serverless.
Okay. Serverless.
Tell me about serverless.
Well, serverless is basically just the use of third-party services to run your code in the cloud without the need to manage servers yourself. It's an architectural pattern, and it's commonly used to build APIs, but as well as HTTP requests, you can also respond to other events like emails or queue processing, or even voice commands for home assistants. AWS Lambda is probably the most famous third-party provider, and the other services that AWS provides around that. But Google, Microsoft, and IBM all have similar offerings. It's not really no servers, so much as we're eliminating servers from the things we have to worry about when we're building our online service or product. We're handing over to the third-party provider all those concerns about provisioning our code, scaling it, and ensuring that there's acceptable redundancy. So it's a shift in mindset from traditional infrastructure, and it's kind of the latest step in this evolution that we've been going through, from bare tin through to virtual machines, through to containerized platforms, and now here we are at sort of serverless.
So you mentioned there, bare tin, for example. What are the challenges, in your opinion, with that approach?
Yeah, so traditional infrastructure, it takes time and effort to provision and maintain. That's really it. Also, it costs a lot. So if you're talking about bare tin and managing your own hardware, then your lead times can be quite long. If you need to scale up and order in more or expand your slice of the co-location, that can be slow, and it's definitely expensive. But even when you go into more modern things like virtual machines, containerized platforms, there's still the time that you have to spend, your developers and your operation teams have to spend building out and creating kind of resilient and highly available infrastructure. And that's the stuff that's not really delivering your business value. That's not your product or your service. That's just the stuff you need to run it. Scalability is also a challenge. So if you need to be able to accommodate spikes in traffic or seasonal variations in demand, you have to have a strategy for how you're going to scale up your infrastructure to handle that. And that can cost a lot. Sometimes you're going to have some reserved capacity there just to deal with those spikes. and that's sitting there actually doing nothing and just costing you money. And of course you've also got the operational overhead. You're sitting there, you have to be making sure that your servers are up and healthy, and you've got to employ people to do that, or take some time away from developers to do that. So those are all things that kind of just go away with serverless.
Oh, that's brilliant. So how do you identify a good opportunity to use serverless?
So I'd say serverless is classically really well suited to microservices architectures, especially where you can break down your service into very small components. And it's really great when you need that scalability and you only want to be paying for what you're using at any given moment. You need, however, to be able to tolerate a little bit of extra latency, because you don't have dedicated hardware sitting there with your service ready to go, waiting for requests. There can be some additional startup time when your third-party cloud provider is putting your code into a server and then executing it. It's also a really, really good candidate for when you have kind of event-based architectures, and like I said, it's not just HTTP requests that are events, but like emails and scheduled tasks and queue processing. That's a really, really great candidate for serverless.
Fantastic. So if I decided to choose serverless, how does it change how I might maintain all the services that I'm running?
So like I said, with your traditional infrastructure, you've got all this overhead and all this cost and time that you're spending to maintain that. And a lot of that just goes away. So serverless is great for when you're talking about continuous deployment into prod. You upload your code, and it's just there. It's ready to go the next time your serverless function is executed. That's the latest version, and there's zero downtime. So that's really great. You're essentially deploying a set of microservices like a monolith. Everything goes out at once at the same version, and so you avoid some of those usual headaches you have with making sure that everything talks to each other with the correct versions, and if you need to maybe deploy things in a certain order, you just don't have to worry about that so much anymore. And also, like I keep banging on about scalability, I mean, it's basically taking care for you. I mean, you get pretty much infinite scalability, and your serverless functions are very, very unlikely to be the bottleneck in your system.
Sounds great. I'm sure there's some people out there who want to know when it shouldn't be used. So in your experience, tell us a little bit about when serverless is not a good idea.
Yeah, so I mean, for starters, you're not going to be able to take your massive monolith and just take it off your traditional infrastructure and stick it in serverless and sort of job done. And deployments, as in general, aren't a solved problem. You still have some of the challenges of deploying a fleet of microservices, possibly exacerbated a bit because they're a bit smaller than usual. You've probably got more of them and they're smaller. And it's quite difficult to do things like blue-green deployments. I mean, it's pretty much like big bang, everything goes out at once. So management can be tricky. Like I said, you've got lots of things going out together. You do still need to manage your interdependencies between them in the same way you would with a microservices architecture going out on traditional infrastructure. So although you do get some benefits in terms of forgetting about some of the problems of versioning, you still have to handle those in different ways. There are frameworks coming out which are looking to address some of these challenges and sort of plug some of the gaps in the different cloud providers' offerings. But these frameworks are still pretty immature, so you have to have a certain appetite for living on the leading edge, as it were. So a couple of examples of those, probably the biggest and most mature of them is actually just called the serverless framework. And that's quite good in terms of being fairly agnostic of cloud provider. I mean, you can deploy it to several different companies' offerings. There's also Apex and Chalice, which give you some different capabilities. Those are specific at the moment to AWS. But these are like rapidly evolving, and it's quite an exciting area and lots of activity happening. So we can expect those to get more mature and become even better, make some of these problems even easier to deal with.
So you mentioned there different service providers of serverless. Are there any differences between them? really?
Yeah, I'd say the main one is kind of just the technology support, the language support. So, for example, Google Cloud only supports JavaScript. So that might rule you out immediately if you're not a JavaScript shop. AWS also will allow you to deploy serverless functions that are built with JVM languages like Java, also .NET and Python. And Microsoft Azure adds even more with PHP and some scripting languages like Bash and PowerShell, if that's your thing. But other than that, really, I mean, the pricing is pretty similar across the board. All the providers are offering very generous free tiers, so you can get about at least 1 million invocations of your serverless functions every month for free. And even after you break that cap, it's still extremely cheap. We're talking like $1 per million invocations. So, like we said, it's much cheaper than traditional infrastructure. In fact, we've seen like orders of magnitude cheaper with some of our projects.
Wow, brilliant. Thank you for that. So, to the floor now. Does anyone have any questions for either Stu or Andy? I have a question while we're waiting. Yeah. What happens if I want to use both technologies? How do they work together?
Yeah, absolutely. There's nothing stopping you hosting a GraphQL endpoint in a serverless as a function. We've done that. It works really well. Like you said, with the latency issue, you know, if it's a frequently used service that's going to be hot, and if otherwise it's going to be cold, and cold starts a bit slow. But for the main point, I mean, absolutely, definitely.
I think also, I mean, as well as hosting your endpoint, like you said before, with traversing your graph and using resolvers to fetch the different bits of data you're assembling for the client, those resolvers would be really good candidates to be serverless functions themselves. And especially when we're talking about scalability, I mean, when you're fanning out across this graph and spinning off lots of different requests to resolve those different chunks of the response, I mean, that's where the scalability of serverless will really come into its own.
Yeah. Any other questions at all for these two? Great. Well, if you think of anything that you would like to ask, either Twitter handles you can see on the screen at the moment, or you can also email your questions to bebold@red-badger.com.